In this video, we are going to be looking at carbon-carbon bond formation, which is quite a useful technique to know when it comes to doing organic synthesis. So there are a few ways to do this. The first way we could do this is going via a nitrile. So let's just remind ourselves what we mean by a nitrile. A nitrile has this functional group where we have a carbon triple bonded to a nitrogen, and that is a nitrile group. So the ways that we can make a nitrile is by doing nucleophilic substitution using a cyanide ion with a haloalkane. So let's just do an example of this. If we have chloroethane, we can react that with sodium cyanide, and that will produce this nitrile here and also release sodium chloride. And in terms of the mechanism, it is nucleophilic substitution, so I'm just going to draw this out. So we've got a cyanide ion. Remember, the negative charge and the lone pair of electrons are on our carbon. So this is acting as our nucleophile. We have a dipole across here, and we just do nucleophilic substitution to form our nitrile compound. Like so. Okay, so this is one way that we can extend a carbon chain. So in this one we had 2 carbons, and in this one we now have 3 carbons. Okay, we have also done the reaction of cyanide with our carbonyl compounds like ketones and aldehydes. So let's just run through that as well. So in this one we don't form a nitrile, it's called a hydroxy nitrile. Okay, so let's look at how we form a hydroxy nitrile. So we start off with a carbonyl compound. I'm just going to go for ethanol. And again, we use so sodium cyanide with acid, and we do our mechanism like this. So this is now nucleophilic addition, and we form that, and this is why we have to have acid present to protonate this, and from this we form our hydroxy nitrile. Like so. Okay, and as you can see, we have extended our carbon chain again. So in this one we had 2 carbons, and now we have 3 carbons in this compound. Now, once you've formed your nitrile, there's a few things you can do, or once you've formed your hydroxy nitrile. The first thing we can do is the reduction of that nitrile. Okay, so let's have a look at that. So reduction of nitriles. Again, it could be a reduction of the hydroxy nitrile, either is fine. So if we have, for example, let's go for this compound here. Okay, we can reduce that by reacting it with hydrogen. So this is essentially the hydrogenation reaction of this. So like we do with alkenes, we need a nickel catalyst, and now we actually need 2 lots of hydrogens because this is a triple bond that we're reducing, and this is going to form an amine. Like so. Okay, so we've reduced our nitrile, or essentially we've hydrogenated it, we've added hydrogen across that triple bond there to form this primary amine over here. Another thing we can do, so other than reduction of nitriles, we can do the hydrolysis of nitriles. Okay, so if we've got, let's just go for that same one, so CH3 with a nitrile, we can convert this into the corresponding carboxylic acid. Like that. For this we would need to have acid and also H2O present, and you would also need to heat that as well. Okay, in order to write the balanced equation, so plus HCl plus water, and this is going to form the carboxylic acid, and it's also going to release a salt as well, and in order to balance that we need to have a 2 there. Okay, so this over here is the overall equation. This is the balanced equation down here at the bottom. Okay, so that's what we can do with our nitriles. Once we've formed a nitrile, we can either convert it into a primary amine or we can convert it into a carboxylic acid. Right, there are 2 other ways that we can form a carbon-carbon bond. This is what we looked at when we did aromatic chemistry. If you remember, the alkylation of benzene or an aromatic compound even, alkylation of benzene is where we have a benzene or even an aromatic compound, and we react that with a haloalkane. So I'm just going to go for something simple. We also need to have a halogen carrier present, and this forms a new carbon-carbon bond, so between a carbon on the benzene ring to the alkyl group on that haloalkane, plus releasing HCl as well. Okay, so this one we have formed a new carbon-carbon bond. And also similar to this is the acylation reaction of benzene. So the alkylation and the acylation are also known as Friedel-Crafts reactions. So in this one, we are now reacting it with an acyl chloride. So for example, ethanoyl chloride. And again, you need a halogen carrier. And in this one, we now form our new carbon-carbon bond with this group here. And that's our new carbon-carbon bond formed there. And that's our other product. Okay, so for the alkylation and the acylation, you should know what the mechanism is for those. That's what we covered back when we did aromatic chemistry. Okay, so these are just a few kind of ways that we can make new carbon-carbon bonds. One is going via nitrile or hydroxy nitrile, for which you need to know the mechanism for, and you should then be able to do reactions of nitrile. So nitriles you can reduce to primary amine, or you can do the hydrolysis to form the carboxylic acid.